Okay folks, it's going to be weird today. The Atlantic Ocean is suddenly cooling rapidly and scientists are completely at a loss. Shouldn't it be getting warmer? And do we need to worry now? Make sure you stay tuned until the end to find out. Welcome friends. Atlantic temperatures are dropping, quite the opposite of my subscriber numbers. If you want to learn more about such fascinating topics from science and nature, then leave a subscription for the channel. Subscribing doesn't cost a penny, you'll never miss a video again and you'll help me immensely. Thank you friends. Imagine planning your summer vacation and looking forward to a nice swim in the Atlantic. But when you jump into the water, a surprise awaits you. It's freezing cold. Don't panic, you haven't accidentally traveled to the Arctic. In fact, the Atlantic Ocean is cooling down at a record speed and scientists are baffled. I can already hear some of you asking,
wait a minute, cooling? What about climate change?
Well, nature has apparently decided to surprise us with this unexpected twist. But what exactly is going on here? According to data from the US National Oceanic and Atmospheric Administration, INWE for short, the cooling of sea surface temperatures in the Atlantic began as early as May, and since then the ocean has been 1 to 2 degrees colder than usual for this time of year. That doesn't sound like much at first, but imagine if your body temperature suddenly dropped by 2 degrees. That would be enough to get you off work sick, wouldn't it? You lazy bones. You might wonder if this isn't actually good news. After all, we hear about the warming of the oceans and their catastrophic consequences all the time, don't we? Unfortunately, it's not quite that simple. In climate research, the following principle often applies. Extremes in both directions are not so good. It's like a relationship. Too much closeness can be stifling. Too much distance lets them cool down. Nature and love like it balanced. To understand why this cooling is so surprising, we need to take a brief look at a weather phenomenon that sounds like it was invented by a Spanish-speaking babysitter, El Niño. This climate cycle occurs every few years and causes warmer temperatures in the eastern Pacific Ocean. Its counterpart, which causes cooler temperatures, is called La Niña. Think of it as a planetary thermostat with El Niño turning up the heat and La Niña hitting the air conditioner. Normally, scientists expect Atlantic temperatures to rise at this time of year, partly because of El Niño. Indeed, the Atlantic has been setting one heat record after another since March 23rd. But now La Niña seems to be taking control earlier than expected. The change from El Niño to La Niña should not occur until September. The fact that it is happening prematurely has left even experienced climate researchers at a loss. Franz Philipp Tuchen, a postdoc at the University of Miami, put it succinctly, "We have gone through the list of possible mechanisms and so far nothing really fits. If temperatures remain half a degree cooler than average for at least another month, then it will officially be called an Atlantic Niña." But what does that mean in concrete terms? First of all, it could have an impact on precipitation in the surrounding continents. Imagine planning a trip to Brazil and packing an umbrella just in case, only to find that it is suddenly much drier than expected, or looking forward to a sunny vacation in East Africa, only to have to pack your rubber boots at the last minute. Nature seems to be having fun messing up our weather forecasts, and it gets even more exciting when we look at the possible effects on the hurricane season. And I'm not talking about Harry Kane's upcoming season at Bayern Munich, but tropical cyclones. The NOAA has found that Atlantic Niños can increase the likelihood of hurricanes near the Cape Verde Islands. With the sudden cooling, that could change. The Pacific Niño is expected to increase the likelihood of Atlantic hurricanes when it arrives in September, but the Atlantic Niño can weaken certain conditions, such as atmospheric wave activity that are necessary for hurricanes to form. But the effects could be even more far-reaching. Michael McFadden from NOAA points out that this change could also affect ocean cycles. He speaks of a tug-of-war in which the Atlantic tries to warm the Pacific, while the Pacific tries to cool itself. Imagine it as an epic battle between two oceanic titans, with us humans standing on the sidelines like little ants, watching intently. But why is all this so important? Well, the oceans play a crucial role in the global climate system. They store huge amounts of heat and CO2 and thus influence the weather and climate around the world. An unexpected cooling of the Atlantic could therefore have far-reaching consequences that we cannot yet properly foresee. It's like suddenly replacing a gear in a huge complex clockwork. You never know exactly how it will affect the rest of the system. Interestingly, however, this cooling comes at a time when global ocean temperatures have just ended a record-breaking 15-month streak. Pedro Dinezio of the University of Colorado at Boulder confirms, "We are beginning to see that global mean ocean temperatures are declining a little. A bit like the Earth, after a wild hot party, decided to cool down for a while in the pool with a cold drink. However, a short-term cooling does not yet refute the long-term warming trend of the oceans. It's more like a short breather in the marathon. So what can we learn from all this? Above all, that our planet's climate system is unbelievably complex and full of surprises. Just when we think we've got it all figured out, nature shows us that we still have a lot to learn, and that this complexity massively exceeds our current level of knowledge. This is a reminder of how important continuous research and observation are. I recently spoke at length with Professor Dr. Andreas Fink from the Institute for Meteorology and Climate Research about El Niño and La Niña, and I was really impressed by the way he described the methods used by scientists. Let's take a quick listen. I have another quote from you. We don't see a signal on the surface yet, but below about 100 meters depth, we already see colder temperatures in the eastern Pacific, which is an early sign of La Niña. Measuring above 100 meters depth probably works better with simulations like this.
No, it's interesting and nice that you brought that up. It's true that you can see the signal in the ocean at a depth of 100 meters. This is due to the changes in the thermocline, the temperature thermocline, caused by the waves. It can only be seen at this 100-meter line. As early as the late 1980s, which was mainly financed by the United States, because they were very badly affected by an event in 1982-83, anchored buoys were introduced into the Pacific, I'll say now every 10 degrees of longitude at the equator. So a network of buoys, and these buoys are anchored. They measure temperature, wind, partly rain, pressure at the surface, and they have a line that goes into the ocean. And on this line there are further measuring devices that measure the ocean temperature and the salt content, for example. And this network is extremely important for us and for the initialization of the models. That was really a great step towards better simulation and observation. These moored buoys also exist in other regions, but it's very expensive. And believe it or not, a container ship often tramples over them and destroys them. But this buoy network is extremely important and has existed since the late 1980s.
Yes, what do you think? What is the real cause of the cooling of the Atlantic? Why have scientists been unable to reliably predict it, and why are they so surprised by it now? Feel free to write your thoughts in the comments, and if you don't want to miss anything on this topic in the future, don't forget to subscribe to the channel now. Now let's travel from the Atlantic to China. The first commercial thorium liquid salt reactor is going into operation there, and it could be an absolute nuclear energy revolution. What is so special about it and why it will soon be called nuclear power? Yes, please, you will learn in the video shown. Be sure to click on the top right, and if you want to support the channel, feel free to watch the older videos. Every click supports the channel. Otherwise, I would say see you in the next video. Take care, friends.